Believe it or not, a single AA battery can power a DIY welder. Watch this. In the first step, I start with a completely drained AA battery, something most people would throw away without a second thought. But this time it's different. I'll be using the inner core of that battery as a foundation for a DIY soldering tip, built in a simple yet carefully considered way. From removing the outer casing, to slowly extracting the core, and then shaping it into a usable soldering tip, every stage is planned with intention. Nothing is rushed, and no detail is accidental. So, if you're curious about how this process comes together, stay focused, because every step you're about to see has a purpose. A DIY soldering tip made from an AA battery core may look simple, but it serves a very practical purpose for many soldering devices. Its compact size and ability to focus heat make it especially useful for small touch-ups, delicate joints, and basic repairs where larger soldering tips simply can't reach. What makes it interesting is the idea behind it. Turning something usually discarded into a functional tool. It's not meant to replace professional equipment, but rather to solve a problem when you need it, save money, and make use of what's already around you. For small DIY projects, this kind of soldering tip represents more than just functionality. It reflects creativity, resourcefulness, and the mindset of building something useful from the simplest materials. And just like that, a mini DIY soldering tip comes to life. No complex tools, no long preparation. With just a bit of time and careful thinking, you can create a compact tool that's practical enough for everyday basic needs. Next, I prepare a small copper tube and a short piece of PVC pipe. The idea is straightforward. The copper tube will serve as a solid, heat-resistant soldering head, while the PVC pipe will act as a handle, providing better stability during use. To make it more practical, I'll also adjust the size of the PVC pipe so it feels comfortable and natural to hold. At a glance, it's easy to see that the copper tube doesn't quite match the inner size of the PVC pipe. But that's not a real problem. With a bit of improvisation, I use paper tissue combined with liquid glue to fill the gap and secure everything in place. Just a few simple hand adjustments, and the two parts come together firmly and neatly. Once everything is secured, I drill a small hole and add a screw to keep the soldering tip firmly in place during use. Make sure to tighten the screw gently. If you apply too much force, the DIY soldering tip can break easily, and all that effort could go to waste. At this stage, I move on to connecting the electrical wire. For now, I attach one end of the wire to the soldering head, while the other end is left aside. That remaining connection will be handled later when linking it to the positive terminal of the power source, keeping the setup neat and well organized. To make the electrical connection to the soldering head more secure, I don't wrap tape directly around the joint itself. Instead, I run part of the wire along the handle, which helps relieve stress on the connection and keeps the whole setup more stable during use. This is a metal clamp, and I'll connect the remaining end of the wire to it. Its role is to act as an intermediate connector, making it easier and more convenient to link the setup to the power source during use. Of course, there also needs to be a connection to the negative terminal of the power source. I use a single electrical wire with one end attached to an alligator clip for quick and secure clamping, and the other end fitted with a metal ring. This setup makes the connection simple, flexible, and much easier to work with. The power source of this setup is a standalone battery with specifications that are just right for a DIY mini soldering device. Nothing excessive, nothing overpowered, just a simple and suitable solution for the task at hand. There's no need to worry. The AA battery is only slightly damp, and once it's dry, it can be used normally with a DIY soldering device. In reality, the test itself is quite simple and doesn't push this device very hard. So make sure to watch until the end to get a clear and accurate sense of how effective it really is. This part can be considered a small bonus at the end of the video. I'll quickly show you how to fix an LED bulb with a blown LED chip in just a couple of minutes with a simple soldering technique. It's something you can easily do yourself without any complicated tools. The first step is to open the LED bulb cover, then check each LED chip one by one to identify exactly where the problem is. Next, touch each LED chip with a screwdriver. The one that lights up is the faulty spot. At its core, an LED bulb fails because the circuit is no longer continuous, causing the current to break and leak out. Once that gap is restored using the proper soldering technique, the circuit can function normally again. And with that, the DIY soldering machine is complete. It's not meant to replace professional tools, but to show that with a bit of understanding and thoughtful effort, even the simplest things can become useful. If you enjoyed this project, remember, DIY isn't about expensive equipment. It's about how you see and use what's already around you. Thanks for watching till the end, and I'll see you in the next idea.